So today we are going to do data cleaning in SPSS. We will just insert some values in SPSS and try to clean that particular data. And we will demonstrate using a data with a maximum of 10 rows, so that you can understand more, or the same syntax that you will be using to clean data with 10 rows is the same syntax or the same procedures that is used to clean large data sets. So we will demonstrate with what you can see, because I don't want us to do data cleaning processes with the large data sets that has entries of, let's say, 200,000 entries. No, we are doing data cleaning process with the data that fit on the screen, or data that you can see. Indeed, I've done this, and this is the reason why we are getting one data changing from this form to another. So yeah. What is data cleaning? I'm sure up to now you understand what you mean by data cleaning. Let's cutting across from Excel, Power BI, Stata, R, Python, all those things, right? And this is a preparation of data for analysis, where we remove and modify data that is incorrect. Right? We can do away with missing values. We can either replace them with some values or just delete them. Then we do away with the irrelevant, duplicate, or improperly formatted data. You understand the result of doing analysis with the data, you will end up making wrong decisions. So yeah, we have steps of data cleaning that I have documented here, right? So remember, process of data cleaning does not follow a specific order, right? You can start anywhere. You can detect and remove the outliers before you carry out all the other analysis before you carry out other data cleaning processes. That is for missing values, checking for the range values, all those things, right? So we don't have a specific order, but I've documented some here that we are going to use for this analysis, for this lesson, I mean. First of all, we start with the out of range data, right? Checking for out of range data. This can be done, or this can happen due to typographical errors. And an example is you are supposed to enter 1 and instead you enter 11, right? So that is the data 11 is out of range. So because your column might need values from 1 to 5, but you end up typing 11 mistakenly, or 22, or any other value that is out of the range. So now, how do we remove an outlier? How do we remove data that is out of range, right? How do we detect the data that is out of range. We always use box plots. We always use box plots. You can box plot values, let's say from if we box plot a column that has values from 1 to 5, they're supposed to, that column is supposed to carry values from 1 to 5. I expect my box plot to be in between 1 and 5. But if you have data that is out of range, for example 11, you will, the tail of the box plot will go up to 11 or any other value. So any other value that is out of the range. So we'll demonstrate how we do away with it. We have the irrelevant data. These are parts, variables within your data set that are not useful for the analysis that you are doing, right? So we're doing an online survey, for example. The platforms for data collection might collect the start and the end time of a survey, right? The email of the GPS, the email or the GPS of the respondent. So to get rid of these values, because we don't require them in our analysis, we don't require email values to do our chi-square or GPS to do our analysis, we can get away with those values by right clicking the variable name, then we clear. So I want us to insert some values in the SPSS, then we continue with our data cleaning process. And as we said yesterday, this is a variable view. This is where you define your variables, and from the data view you can insert now the data itself. So I want us to create a simple data set, and the first one, the first variable is let's create data concerning your income. So your income and expenditure, right? So the first variable, let's have name. So name. Okay, before we continue, name is of which data type? When you click on the 3 dots here, I want to hear from you. Date is of which data type? The name I mean. Yes? Name is of which data type?
String.
Yes. Name is of which data type? Today I want us we do practical. Nikifanya hapa you do in your machine, right? Name is name is, I want to hear from you the data type for name. Data type for name. Frida, welcome back.
Someone said string.
Yes. So these are string, right? Kama sikusikia, so let me remove these ones. Okay, name is a string. Name is a string. You just insert, you just check that box for string, and width inaweza kuwa na 10, right? Let's say 10. What's the data type or not? What's the measure for name? I want you to think as statisticians. Measure for name. What's the measure for name? Is it nominal, ordinal? These are nominal, isn't it? These are nominal. I want us we have our second variable as income. Income is number, let's say numeric. Okay, and what's the measure for numeric? What's the measure for numeric? What is the measure for numeric? What is the measure for numeric? For the income variable.
Ordinal.
Ordinal, right. This is an ordinal. Very true. Which other variable do you want us to have in our data? Let's have expense. So let's have expense. The expense is a numeric, ordinal. Which other one? Another variable?
Gender.
Gender. So that I can show you how we code the gender. Gender is it in numeric or string? I want to explain something here before we continue. Is gender numeric or string?
String.
Another one? Okay, we learn by mistakes. How will software understand male? And how will gender understand female? How will the software understand female? Will it be able? No, it will not be able. Yes?
Gender is supposed to be treated as numeric.
Yes. Let's treat gender as a numeric, then we code that value. So let's say these are, is it ordinal scale? Is it ordinal or scale or nominal?
Ordinal?
Yes. Gender is ordinal. Okay. Just a minute. Let's continue now to do this. Let's code gender. So here we have to click on values. So that we define gender. This software is designed to understand values, not strings. In calculations, I mean. In mathematical calculations, we don't do calculations on strings, right? But if we code or if we tell the compiler that this value represents gender, this value represents male and female, then we will be okay, and the compiler the software itself will be able to do calculations based on those genders. Now let's say value 1 to represent male. So you type 1, label, you type male, and click add button. So click add button. Number two is female. So is female, so we click add, inakuja huko, then we click OK. I want as we remove this decimals there. Now let's have these values. Now click on data view to add the values, right? Let's say the first one is John. Excuse me. The first one is George. Just add any values, right? Second one, and fourth one, karaoke. For the one, okay, and for the one, Laban, another one, Mary, another one, Jessica. So those are names. On income, just insert any value. Insert any value. Expense, insert any value. So gender, insert values between 1 and 2. So insert values between 1 and 2. No, for this one, yes, we have those values. I want as we create duplicates. Let's create duplicate for Mary and Jessica. Those two, highlight those two, copy them, kuja nazo hapa, add them there. So I want as we have just that kind of duplicate. So kila mtu amefanya hivyo. Kila mtu amefanya hivyo, right? Frida, are we together? Are you following what we are doing?
Yes, just that I'm having network problems.
Oh, really? So others,
Yeah.
just to follow and do it in your machine, right? Okay, now we have the data that we are going to use for demonstration. I want as we add another column. Here. So on variable view, just add email. So email is string data type. So then click on data view and add the emails. So blah blah blah. Just insert any values. Just insert anything. So those are emails. Those are the emails. nataka kuwapea dakika mbili, you do that, then we continue. Tuko sawa mpaka hapo? Mr. John?
Add county.
Okay, let's add county. So if you want to add anything, you just go to the variable view and define what you want to add. So county is string. Okay, and let's add counties here. So add your own counties, right? So this is Meru, Embu, Nairobi, Murang'a, Kakamega, Vihiga, Mombasa, which is the other county, Murang'a. So let's have those values. So we are together up to that point, right? Sit down. Joy Morengi, welcome back. Welcome back. I hope we are there, all of us. You have this kind of data. So while you are there, we can now continue with the processes now. Suppose we don't have we think that email is irrelevant in our analysis. Suppose that we think email is not relevant in our analysis. I think that's where we were. So these are irrelevant data. So click on the first variable that you want to clear, then press control up to bottom, then you just clear. So you can also have irrelevant cases too. So in a case when you are dealing with the highest level of education, primary school, secondary, tertiary, so you may want to analyze only the tertiary level, so you can sort the highest level of education, and that is variables in ascending or descending order, and then clear the unwanted cases. So let's see how we do away with irrelevant data now. It's very simple. You just click on the email. So click on the email, or the variable name itself. Click on email, then right click and clear. Right click and clear. Are we together? That's how we do away with variables. On cases, remember cases are represented by rows, so you can just right click while your cursor is there and drag across the cases that you want to delete. You just right click and click on clear. So and click on clear. Let's continue. So what are the outliers? Okay, outliers out of the range. So these are values that are extremely lower or higher than majority of the data, right? So they tend to skew result towards their direction, depending on the incorrect information. To identify them, sort the data in ascending or descending order. Another way is to use box plots. Ensure that the data is formatted properly, set in order to carry out the function. So we can box plot. Let's insert abnormal data here and try to do the box plotting. Let's insert John as our case. Then on the income, let's insert a very huge value. So a very huge value. And expense, we insert very huge value. This mail from Nairobi. Are we together? So you can click on chart builders so that you can detect that outlier. So you go to the graph, then chart builder. So you just click on graph, chart builder. Let's see. From there, you drag to the box plot here. So. Then you can click one of these box plots. So double click one, and when you double click, you'll notice that the one box that you have will be active here on the chart preview, right? From there, let's insert income on the x-axis. So this is the income. So you right click. So if you want to bring your income on x-axis, you just click on the income, then right click, then drag it up to the axis that you want. So up to the axis that you want. But now I want to do away with this one. Let me reset this and have only this one here, right? I have only one box plot, so double click on it, then drag the income. Let's see. This one will not make sense. No, let's use this one here. We have this category 1, category 2. Let me check. I think this one is not making more sense. Let's use the histogram and see what happens. Let's use the histogram, then plot income on the x-axis. So these are category 1, category 2. Let's click OK and see what we will get. So we have the values here, but now this one will not make more sense, because what we have here, we want to detect this one, right? We want to detect this one. So which other plot can we use? Let's see. Let's try our box plot and see what happens. and drag income. We can drag income on that one. Let's have the values of expense on y-axis and click OK. And click OK. Let's see. And click OK. Okay. This is a good example. With this one, you can check. We have income here, and the income is the point for the income is the highest in these charts, right? Is highest in this chart. So I expect all my point to lie between 23 and 234. So anything outside is an outlier. So you can detect these as an outlier, and you can delete that specific figure. So yeah, that's how we do the outlier detection. We have incorrect data format, and an example can be number stored as text. What is your age? What is your age? Stored as a string instead of numeric, right? So you cannot do the analysis of let's say regression if your data is not in the correct format, right? Let's see. Suppose income and expense. Okay, we have these values as numbers. So even changing from numeric to string, all these values will not be there. Let's see. Suppose we want to change this from numeric to string. Click on string and click OK. You will have a message somewhere, and click on data view. String expense, then income. Let insert also string. Yes. From there, just click on analyze and try to run a regression analysis between income and expense. So remember, the data type is in string format. Click on analyze and click on regression, then click on linear. We have income. Click on income and try to bring it on this box for the dependent. What's the message? String variables are not allowed in this list. So it means you cannot run a regression analysis of these two variables because they are not in the correct data format, right? But now let's suppose let's try to change these data types to numeric. Let's see. So from string to numeric. So these are simple things that you need to understand as you master this software. Click on analyze and try to run the same regression analysis with income, then bring it here. So you can see now you are able to bring these values or these variables from this side to this other side for analysis purposes. So from there you can just click OK and have your regression. You as data analyst, you understand how we interpret these regression tables. So tutafika hapo siku ingine. Another thing is on the duplicates, and I want you to be very keen here. You can see that we introduced some duplicate cases here intentionally. Let's see which values ni value gani iko duplicate. Jessica and Mary, right? Is Jessica and Mary Jessica and Mary? Okay, I want us to be keen here to know what is happening. Mary 56 female, so we change this to Mombasa. So we change that value to Mombasa. We have Jessica 879 234 male Viga. So this person is from Viga. Okay, let's now try to detect the duplicate cases and delete them. You can check out for values that are supposed to be unique and specific to each respondent or each case. Record in the data. Then there can be duplicates for index number, email collected, or phone numbers, right? So we can just check for duplicates on a specific column all across the whole case. So the best treatment is just to delete them from the data. SPSS has a special way for that. How do we identify duplicate? You just click on data and identify duplicate cases. So click on data, identifying duplicate cases. So this window will pop out. Let's continue and see. Click on data, then identify duplicate cases. Click on that one. We have the variables here now. So these are window will pop out. So this window will pop out there. What do we do next? Let me automate this one. So the next thing to do is to drag and drop the variables you are checking for duplicate into the define matching case by slots. So define matching cases. So define matching cases of let's say name, then what else do we have here? Under the variable to create sort with a matching group. Let me check some blah blah blah. Okay, kasawa. Under the variable to create, under the variable to create section, you can see that the name slot name of the variable to be created, right? Let's click on OK. Click on OK. Click on OK. What do we have? We have 9 valid cases, no any missing value, but we have 2 duplicate cases. Primary case is the unique cases, right? So if we delete the duplicate ones, we will remain with 7 cases. So these 7 cases, they are unique. Now I want you to do a research on even on YouTube. How do we delete duplicate values? So how do we delete duplicate cases? We have the structural issues. We have the structural issues. So these are typos, spelling errors, inconsistencies, capitalizations, and extra spaces. So you can summarize it using frequencies, and it will show you the unique values with the values within those variables. So right click on variable and do the descriptive statistics for those values. Let's check on the descriptives for income. So you just click on analyze descriptive statistics and try to run frequencies on descriptives, and you will get those values there. Let's see for the income. For the income, it's very easy to note that this is an error. So these are typing error, so we don't expect values, any valid value to be this big. So we expect it to range on a reasonable figure. So we expect our values to be in a reasonable figure. So from there you can just go and delete this value or this case. So and process of data cleaning is not that simple. You have to sort so that your data, so that the decisions that you make from your analysis report will be free from errors. So which is the other one? Those are just structural issues. Identifying duplicate, fine. Okay, another thing, this software is case sensitive, right? This software is case sensitive. Suppose that you want to detect gender that was inserted incorrect, right? Suppose here instead of male with capital, we have male with small. Oh no, it will not go through. It will not go through because I already coded this variable for gender. So that one will not be in the as that. How do we find now and replace specific values in SPSS worksheet? That is our next question that we need to ask ourselves. How do we find and replace this kind of any value in SPSS? The process is simple. Suppose that I want to find and replace 234. So I don't know where that value is, but I know it's within the column. So you just click on that column. You just click on column name. The whole column will be highlighted. Then click on Control F for finding. Control F. Control F. We can find any value, or we can just replace any value. Suppose we want 234. Find the next. So we have this 234 there. So suppose we want to replace that value. We want to replace any 234 with 1000. Let's say, for example, 1000. Click on. You can replace all, or you can replace each value. Just clicking on replace. So click on replace all, and we have one replacement were made. So SPSS has finished searching and replaced one variable. You just click on OK and close the dialog box. Ukienda kwa the income, we have the value there. We have the value there. Sawa. Priska. Priska, unakamata?
Yeah.
We are together, right?
Yes.
Okay. Let's continue with the next function that we are going to. Missing values. How do we find missing values? Let's delete Nairobi. So. And delete mail. Here we can't delete because we just defined those values. Just delete them. So yes. How do we find missing values? If you are very, very keen after deleting some values, we have a dot in that cell, right? We can use that one to find or to search for any missing value. Let's see what I documented here. So missing values can be due to non-response, or the question is irrelevant to the respondent, right? So that's direct explanation. So can cause biasness in your result. So there are many ways of dealing with missing values. Number one, you can delete these cases with missing values, and you might end up losing a lot of data in the process. Secondly, you can fill in missing values using statistically calculated values such as mean or biased, or pattern observed in datasets. So you can use the mode on any pattern that you observe in particular datasets. So the only issue here is that you risk losing the integrity of the data as you are dealing with the assumed value. So that's the challenge now. Remember, in analyzing data, you try to be very neutral as data analyst, so you let the data speak, right? And the letting filling null or missing values may cause biasness, right? Because I don't know the reason or the specific things that you assumed when inserting those values. So yeah. Number 3 is leaving the missing values in and work around them by filtering them, then do your analysis. Let's check how we do it using this software. Suppose I want to insert, to use min to replace this empty cell. You can click on expense, for example, and click on Control F to find that missing value. To find that missing value, and on this dialog box, you just insert comma and find. Is it comma or full stop? You just click on full stop and find it. So very simple, right? So we have missing value here, and let's also delete this 56 here, so you can delete in your machines. Now our next step is to fill these missing values using mean of this column. So using the means of this column, you just calculate the mean of this column. So click on analyze and descriptive statistics, and click on frequencies, then insert expense on this side. Let's see. No. Click on analyze descriptive statistics, click on statistics, get mean from the central tendency box. Click on mean. Okay, expense. Okay, so we have the mean. We have mean here. Mean is 105, so I want to replace any missing value using the mean of 105. So the process is simple. Just click on the name of the column name, click on Control F, and click on replace instead of find. So we want to find full stop and replace it with 105. So your data, while doing this, the column must be highlighted. Please, the column must be highlighted. Then you click on replace all. Click on replace all. What the message that you are getting? SPSS statistic has finished searching, and it has replaced 2 values. So 2 replacements were made. Then you just click on OK and close. You are done. The process is very simple, right? Yes. Imputing missing values using the average, so that's what I have demonstrated. Missing values, 5 to 15% missing values within your data is something that might want to look into. So you can do a descriptive statistics on your variable the same way we have done on the expense. Are many respondents missing 1 value or 2 to evaluate the number of missing values in each case. So you can create a new variable that includes how many missing data points for each case. How many for each case. So that is it. Transforming a missing variable. You can define your target variable as say missing data. So in the function group, you select missing value, then in the function and special variable, select the function you want. So again, you can record the variable with the missing value to form a dichotomous variable where you can now run say test blah blah blah. So you go to transform record into different variable because we are making a new. Let's try to record a new variable. So we delete some values here. So click on transform and compute new variable, record into different variable, then record into different variable. We are recording expense. We are recording expense. Then just a minute. Let us use income. So we are using the expense. So we define the old and the new value. Say for old to be okay for the old. Let's say this is our no. All the values system missing. Just a minute. So the old value we are using 0, right? Let's see. New value to be defined by 0. So new value is to be defined by 0. So define any other value under by 1 under the new section. Let's see what will happen here. So you just click on add and click on continue. And which label are we using? So these are expense 1 label. We are using 1. Let's see. So for the I think this one is more complex, so we can do away with it. Let me admit this student here before we continue. Another thing, we can also transform missing values using the replace missing values functionality. The same we have replaced using the replacing by clicking on transform replace missing values, and we can use series means to replace the missing value. We can run a paired sample t-test to make sure that there is no huge difference between the transformed variable and the initial variable with the missing values. Click on transform and replace missing values. Let's see. So we are using this column for the expense. Transform and replace missing values. We have replaced missing values here. So expense we are replacing these missing values using which method we can use. So we have so many methods here. We can use the series mean, or the mean of nearby point, median, linear interpolation, or linear trend at a specific point. So just click on series mean, so the name of the variable will be expense 1. Just click on OK, and let's see what is happening here. We have the result variable, replace missing values. So we have replaced 2 missing values. I want us to go back here. Now what we have is the name of the new column, right? We have these values now replaced on this part. So remember, the mean of our column was 185, and our new variable with no missing values is the expense 1, and because this column has been calculated from this one, this software will assign it the scale measure, and on the label we have S mean of the expense. So in our analysis, when you do any analysis, you will be getting this label now, replacing the expense 1 variable. So it will be replacing the expense 1 variable. I think that was the last slide for this presentation. If you have any question, you can ask any question, or anywhere that you need some clarifications on. And for those who haven't sent their Power BI report, just do hurry. You are submitting it late. Today is on Tuesday, right? And a day after tomorrow, you are still getting a new report, a new project. So if you will not submit it by tomorrow, then sijui tutafanyaje. This report will benefit you a lot. Yeah, they're just there for evaluating, for your self-evaluation, right? So I will not be benefiting from those projects, so it's upon you to do those projects in time, ili usisahau chenye umejifunza. So if you don't have anything to say, we can invite Mr. Boniface. If you have something to share with the class, feel free. Yes, Boniface. John Karaoke.
Hello. Yeah.
Yeah.
Yeah. I wanted to mention something about the projects, and maybe those who have not been submitting or maybe haven't submitted their projects. you realize that we won't issue the certificates minus seeing the projects that we've been giving you. So if you want to do them at the end of like the program, then well, that's up to you, but it won't really serve you any good for you to stay all this long going through different packages and then you do the projects at the end of it all. So take keen note of that, that you do the projects at the end every week and submit them in time. So the Power BI project that was released, do submit it. And also John Karaoke, we and maybe and do again. So John Karaoke, hit me the inbox. Yeah, that's what I wanted to say.
Okay. If you don't have any other concern, we are done with today's class. You can leave.